Okay, let me launch into all of this. Hello, everyone. It's my distinct pleasure to welcome you today to the first webinar in the RENCI Accelerating Collaborative Team Science webinar series, which we are calling Team Science in the Academic Research Enterprise. I'm Stan Ahalt. I'm the Dean of the UNC School of Data Science and Society. I'm also an executive advisor and domain scientist for Team Science at the Renaissance Computing Institute, also known as RENCI. And today I'll be wearing multiple hats, both as a moderator and a panelist, although I am limiting the amount of time that I'm going to act as a panelist. And I'll be speaking about my experience both at RENCI and at SDSS. And so I just want to say just a few points regarding the importance of team science. Team science is all about how different scientists and other people who contribute to the actual getting science done collaborate to solve problems. And they could be smaller teams or quite large teams. And sometimes they're in very related fields, but in other times they have a very broad set of fields that are being brought together, disciplines brought together. We collaborate because so many problems simply can't be solved by a single scientist or a small group, or even a single branch of science. And so we need to be working together, not in little silos. And so we attempt to bring people together to tackle bigger challenges that face humanity, like climate change or the opioid crisis or global pandemics, storm surge, et cetera, et cetera. And these all require efforts of scientists around the world and across a variety of disciplines to truly understand and resolve the concerns in order to benefit humanity. Climate change, for example, might require input from chemists, biologists, earth and environmental scientists, data scientists, economists, people who analyze risk, and much more, all working together. And so we work together because our ultimate goal is to know and to understand and to ask better questions and ultimately to problem solve. However, we must understand that the nature of teaming and the scientists, best practices that we need to be able to leverage, and potential pitfalls that allow us to avoid making collaborations more difficult than they need to and more impactful and potentially harmonious as possible. Together as a large team science community, we can take on the largest threats and challenges to humanity and all that humanity faces today, some of which are quite daunting. And it starts in meetings like this, where we convene to reach across boundaries and hear one another and collaborate. So I'm eager to hear from the panelists as well as all of the folks who are attending outside of this particular university or this particular activity. So I want to highlight a couple of housekeeping items before we begin. We have disabled Zoom in the question answering for attendees, and all questions related to the panel should be uploaded to Easy Retro, which is our crowdsourcing Q&A platform. If you haven't used it before, it's quite intuitive. Look at the top of the column and you can hit plus and start adding stuff. We'll share the link in the Zoom chat now, and you may find that the platform is intuitive and easy to use. And if so, we welcome you to add your questions and comments throughout the panel discussion. That way you've made a note to yourself that we'll get back to later. Please note that we'll share instructions and the link after our moderated discussion. So a quick overview of our agenda. We'll take a moment to introduce you to our panelists and the institutes they represent. Then we'll spend time in a moderated discussion. We'll share a few key takeaways, and we'll spend some time fielding questions from the audience. So without further delay, let's meet our panelists, and we'll move through the list in approximately reverse alpha order. So please share your name, title, institute, and answer the following question. Is there a certain aspect of team science where your home institution shines, your home organization shines? Another way to think about this is, what is the superpower or the point of difference that you in your home organization brings to the team science at UNC or wherever you're from? So let's start off with Caitlin.
Awesome. Thanks, Stan. Happy to kick us off. Excited to be here. I'm Caitlin Zalchikova. I am a program manager at NC Tracks, and I oversee both our team science program and our new clinical and translational science research program. We have a number of ways that we support teams, including helping investigators to identify collaborators and also directing investigators to team science resources. But NC Tracks really excels in the area of facilitating collaboration among new multidisciplinary teams who are seeking to address complex issues, those particularly in clinical and translational science, where a variety of disciplines need to come together to tackle these problems. And to do this, we have an initiative called the Actor Pilot Program. This stands for Accelerating Collaborative Team Research. And in this program, we really support teams to nurture an initial idea that they have into a collaborative vision, pilot project, and ultimately a collaborative grant proposal submission. So I'm sure I'll talk more about that through today's discussion. Excited to be here and excited to hear from others.
Thank you so much, Caitlin. And next up, let's go to Charette.
Hi, everyone. I am Dr. Charette Godfrey. I'm a project manager for team science at Lineberger Comprehensive Cancer Center. For me, I think Lineberger shines in its ability to collaborate with others at different institutions within the UNC Chapel Hill institution itself, and also just broadly across North Carolina, the United States, and globally as well. These collaborative efforts are also supported not only by the faculty, but also by the staff, the admin, and the senior leadership teams as well. Thank you all.
Thank you. Brandy, how about you?
Yeah, thank you. I'm Brandy Farlow. I work at RENSI as a research proposal and documentation specialist. I also work with the team science group there. RENSI's particular strength in team science lies in its role as a coordinating center. We achieve our best results through the organizational side of team science. So that's large team project management, the development of protocols and best practices, and expert internal and external communications. And all of these kind of work together to ensure that collaboration goes smoothly. Because we have such a solid ability to handle these planning and communication aspects of team science, we tend to have a lot of agility to adapt when situations require change. That said, we also just have a lot of excellent creative thinkers who can innovate to problem solve. And these individuals think outside the box when in the box thinking doesn't resolve an issue. And that is a true credit to our team here.
It's fantastic. Finally, Haley.
Hi, thanks. I'm Haley Brighton. I'm the Associate Director of Grants and Programs at the Institute for Convergent Science, also known as ICS. We're within the Genome Sciences building, right next to Kickstart. And the superpower of ICS is the development of innovative programs within the pre-commercial space that span multiple disciplines and use PIs from different schools on campus. We are truly a pan-campus institute, and our goal is to provide resources for high-risk, high-reward ideas that have great societal impact potential. And team science is a really critical component of our work, of everything we do. Thanks so much.
Thank you. Just real quick, I'm the Dean of the School of Data Science and Society, and the SDSS, as we call it. And I'll just share that we've worked together over the past year to hire over 15 faculty members. And it's been an amazing example of team science, how all the team has pulled together and attracted some of the best and brightest to our area of campus. And we're just really pleased with that effort. And additionally, our Office of Research Strategy has done a fantastic job led by Leanne Sampson, creating a networking opportunities and nurturing a new community around data science, coming together to go after some very difficult problems as a collective. And we're having constant meetings. So I've just been very pleased to be so honored to work with such a wonderful group of people. And with that, I believe that we're going to shift into our moderated discussion. And so let's tell us the mission of your home institution, and then tell us how team science helps to accomplish that mission. And Charette, we'll get started with you.
So for Lineberger's mission is bringing together exceptional physicians, scientists, admins, and staff alike to investigate and improve the prevention, detection, and treatment of cancer in North Carolina and across the globe. For Team Science, our goal is to integrate as well as offer robust support, not only to the research programs within Lineberger that are already established, but also for those future collaborations. We also seek to do this through, or one of the main ways that we do this is through supporting the initiatives of the emerging areas in NCI, which is one of the main funding mechanisms for LCC. And we want to do this in order to increase the extramural funding for team science research, and that's done through P grants, U grants, and multi-PI grants. Thank you.
Fantastic. And I apologize. I'm going to go back up to the prior team science definition slide, which I managed to skip over somehow. Let me just quickly cover that. If you don't mind, Leah, backing up, or maybe it's forward, I'm not sure. Yeah, so I just wanted to share that this is the definition at the National Cancer Institute. So following up by Lineberger, that's a kind of apropos. It's a collective effort to address scientific challenges that leverage strengths and expertise of professionals, oftentimes trained in very different fields. Although traditional single investor-driven approaches are ideal for many scientific endeavors, coordinated teams of investigators with diverse skills and knowledge may be especially helpful for tackling complex scientific and societal problems. So we're going to keep that in mind as we continue on with the moderated discussion. So if you don't mind, next up, the same question, if you don't mind. And next up is, I cannot recall who is next on the list. Brandy, you're up. Brandy, I'm not hearing you.
I suppose it would help if I unmuted. Thank you, Stan. RENCI's mission is to develop and deploy data science cyber infrastructure that helps academic, government, and business researchers use data to drive discoveries, make informed decisions, and spur economic development. I think data science is a field that simply does not function well without all these teams working together. So the next part of our mission actually goes on to discuss building communities of domain scientists, data scientists, technology practitioners, and end users who apply data to catalyze innovation and knowledge discovery. And I think that this community is kind of at the heart of what we do. When I think about some of our larger projects that we work on, one which deals with pandemic responses, another with the opioid crisis, another with heart, lung, blood, and sleep issues, and then the countless other projects spanning into earth and environmental science, pure data science, even software architecture. Each of these projects is enabled by large and small scale collaborations. So in many cases, that could be anywhere from, tens to thousands of different researchers and groups that are contributing ideas and data to enable the science happening on these projects. And it's truly a beautiful thing to see such large swaths of the scientific community working together to solve these huge problems. No individual group could solve these alone. So really, you could say that while being a data science institute, RENCI's chief driver is actually the team science that enables all of these projects.
Fantastic. And I'll just do a real quick answer the same question, then we'll switch to Haley and then finally Caitlin. So SDSS was formed about a little under 2 years ago, and we are focused on real world impact and making sure that we're very practically applied to translational science using data science. And so we have very much focused on joint activities across campus. We've hired the faculty that we've hired the prior year, over 15 faculty. We're going to hire another 15 this year, and many of them are joint hires. And so we are thinking of ourselves as hubs and spokes, trying to bring larger groups together, and very much in harmony with the folks at Lineberger and Trax and other institutions around our campus. But in addition, we hope to be partnering with folks from Duke and NC State and other institutions around the state and the country. So with that, I'll turn it over to Haley next to talk about the home institution and how team science helps that mission.
Thanks so much, Stan. So similarly, ICS has been around for about, we started about 1.5 years ago. And on our website, which is convergent.unc.edu, you'll see that our mission is put research to work. So we aim to support innovative convergent research that has commercial potential, but within the pre-commercial space. So that's prior to company formation. And team science kind of starts the whole process. So without team science, we don't have programs. And so using the science coming out of interdisciplinary teams at UNC, we can help move basic research ideas into the transformative applications that then have pre-commercial and then potentially commercial capability.
Fantastic. And so finally, I think, Caitlin, you're up.
Yeah, so I'll start with TREX's overall vision before I dive into the mission. And the vision is a healthier North Carolina through innovation. And our mission, more specifically, is to accelerate high impact research to improve human health and advance health equity. So team science, as you might imagine, like other folks have said, is really integral to these teams coming together and to track vision and mission. It's a thread that's woven through everything that we do, even if we don't explicitly mention that this is what we're doing. Our team science program has focused on bringing teams together through, like I mentioned, our actor pilot program for kind of building and developing teams on campus. And because we can support these teams early on, we can help bring together investigators who may not have previously interacted much with each other, reduce the administrative hurdles that would often pop up for these new teams at a critical time point where the teams could break down or fall apart. And we can leverage our team science resources and knowledge to help make the teams more efficient and effective, streamlining their processes, maybe creating shared resources and providing that project management. And helping to advance that work that our teams are doing by making them more effective and efficient, we're able to make strides towards a healthier North Carolina through this collaborative high impact research.
That's great, Caitlin. Caitlin, thank you so much for sharing. So, excuse me. I should have muted, and I apologize. So next, let's talk about the practical aspects of team science and its role in advancing scientific developments and solving, highly complex problems. So first up, we'll do a quick review of outcomes. And so outcomes are a critical part of measuring successful projects. Leah, I think you can go ahead and advance the slide. Yes. And so I'll start again. Outcomes are a critical part of measuring successful projects. When we think of an academic research enterprise, how does a team science approach impact the outcomes? And let me go and I'll ask Haley and then Charette, and then we'll see if anybody else wants to pipe in.
Sure. So a few outcomes of team science research. One key component for us is innovation. So bringing researchers together from different schools and diverse expertise, this team science approach can generate new ideas, approaches, and solutions that would not otherwise be possible. And all of that is wrapped up into innovation. Another one is broader impact and translation. So you can have individual projects that do have impact to that particular field. But when you bring team science approaches from interdisciplinary expertise, you have much broader impact capabilities. And then another one that is central to my work at ICS is increased funding opportunities. So agencies are more and more prioritizing interdisciplinary research initiatives that can address complex societal challenges. And team science can greatly enhance your competitiveness and the ability to actually get these funding opportunities, particularly in the larger scale projects and applications. So those are three main ones.
That's great, Haley. Charette, would you like to add anything?
Yes, so similar to the core mission of team science here at LCC, collaboration is very important, but amongst collaboration, integration is very important. So when we're working with all of these different grants, especially multi-PI grants, being able to integrate the different research that each one of those teams are going to provide is something that's fundamentally important. If you're able to integrate the output that's expected from your project, whether it just be something that's going to provide a potential preventative measure, a therapeutic output, or even something that's physically output, integration is one of the biggest things that team science helps to contribute.
Okay, with regards to this first question, anybody else want to pipe in and add anything?
I'm happy to jump in, talk a little bit more about our actor program. We've seen kind of firsthand the power that team science resources and project management can have on our team's success. There was a time before my time when tracks used to bring folks together to discuss, maybe a funding opportunity or brainstorm collaborative efforts. And at the end of these workshops, sometimes we'd see investigators go their own way. It might take significant time for an effort to get off the ground, or maybe that effort wouldn't get off the ground. So to address that valley of death, we created this actor program to provide the infrastructure to kind of support the teams through that stage. And we've seen how that impacts outcomes. I can be specific about that in that one of our teams, which has 23 team members across 6 departments and schools, they are also partnered with RTI. They've held many brainstorming and strategic meetings over the course of the last couple of years that we've supported. And throughout this time, they've managed to collaborate on a manuscript, submit 12 grants together, 7 of which were funded, totaling over $5 million. And that's just within the last, year and a half or so of working with them, maybe 2 years at this point. But I feel like it's really impacted the outcomes specifically in that case, and with another team that we're working with as well.
That's a great anecdote, Caitlin. It's really nice to hear that kind of success. I think you all should be very proud. Anybody else have anything to add, or else I'll move on to the second question. Okay, let's move to question number 2. So let's talk about some practical aspects of team science and its role in advancing scientific developments and solving complex problems. So what are the signature elements of successful team science efforts in the academic research enterprise? And I'll let Caitlin go, and then I think I'm going to offer up to any one of the other panelists, and I'll wrap it up and finish off this question. So Caitlin?
Yeah, thanks, Dan. I feel like I have a lot to say on this topic from the teams that we've worked with, but I'll just highlight a couple of things. One thing that's really helpful for the teams is to establish a collaborative vision together, and the vision, should have clear objectives and goals that are set and agreed upon by all team members. And the vision can change over time or be revised, but I think it's really helpful to set that vision and then come back to that vision as needed. It's also the most successful teams that we've seen are those who have concrete short-term goals and are also thinking about long-term strategic planning. Short-term goals would be kind of targeting, having targeted team outputs, and those might be, we're working on a publication together or IP together. We are working on preliminary data for future proposals. And then one other area is making sure that, if you're bringing a new team together who hasn't met before, the team members might not know all of each other's expertise or what exactly they do. So it can be really helpful to define that and also clearly define any expectations, roles, or responsibilities of those team members as the team progresses to, submitting a grant application or actually working on a project together. And then lastly, I will say from our actor program, robust project management support for team coordination and communication is just so vital to bring everybody together in the same room. And there's a lot of administrative tasks that pop up with team activities. So it's just so important to have that.
I completely agree, Caitlin. Who else would like to add in something? And then maybe I'll speak a little bit from my prior experiences and some of the ongoing experiences now.
I'm happy to jump in on this one. So echoing a little bit of what Caitlin said, I think having a shared sense of purpose and goals, specifically, people are going to come into these collaborations with their own agendas based on where they've been and what their emphasis is. Those things have to be put aside, right? You build a team with the right mix of personalities and note the team dynamics, and then everybody has to get on the same page. And that goes across a lot of different areas. We have to be on the same page on documentation standards, right? How do we name things? How do we file them so that everybody can find them, right? how do we track progress so that everybody on the team is involved, right? So coming to agreements on these early on is going to help really benefit the team. But in addition to that, I would say defining communication tools early, developing a common vocabulary, and sticking to these standards so that everybody stays on the same page is very important. And then kind of last, vital to a successful team science effort, good project managers can help keep a project on task, and also good leaders can help foster that sense of community and equality among team members, which are kind of vital to the life of a project.
That's great. Anybody else want to jump in, or I'm ready to talk anytime. Go right ahead.
I can speak to one other attribute that I've seen. The most successful team science groups that I have seen have been both flexible, and within that flexibility have had creative problem solving, so that when they reach those go, no go points and there needs to be a jump in or shift in what they're working on or how they're working, that motivation stays strong. But that's so flexibility and creative problem solving.
That's great. I'll just kind of riff on that a little bit, Haley. I think the flexibility has to be in many ways an accommodative style. So when we have worked together with different groups who have already established their working patterns internally, sometimes they have very focused and beloved methods that they use or tools that they use. I see that very frequently. And so we at RENCI, and now I'm seeing the same thing at SDSS, have to learn to adapt to people who have patterns of behavior that they want to keep and nurture. And yet, in order to work together, we have to have some common tools. And so I think that being very flexible about your skill sets and be willing to jump into using a new tool, it could be a software package, could be many other things. And I think it's really important for us all to understand that different cultures sometimes have challenges, and the degree of politeness that is exhibited varies from group to group, and assertiveness the same. And so I think that there's lots of give and take that has to happen. And sometimes it really requires very frank discussions with people that might not be terribly comfortable, but will be helpful in the long run in order to help communication be effective. So with that, I think we'll move to our third and final question, and then we'll start using the retro board some more. So as different institutes and departments, units across the campus engage with coordinated teams of investigators, are there specific pitfalls to avoid? We've kind of touched on that to some degree, but let's talk about Brandy, your perspective and the importance of tools for the RENCI approach.
Okay. So some major pitfalls that we've noticed that you have to really be on top of. You lose time due to miscommunications. So clear, concise, precise communication kind of prevents this. We know that the document approval process sometimes, especially as teams get larger, can get really cumbersome. So having a process in place can really help avoid that. Coordinating all the moving pieces on larger teams can also be difficult and time consuming. And honestly, as the team gets bigger, it's harder for people to know what everyone else is doing, all these moving parts, where to send something next for approvals, who you need to talk to get something done. This can be really difficult and definitely something to manage. And then learning to work together, manage expectations, and keep track of the big picture can certainly be a struggle. So it's definitely something, as we said already, that you want to kind of get ahead of right at the beginning.
Charette, how about your pitfalls?
I think one of the big pitfalls is not asking for help and then not appreciating the help. You know, from my perspective, first of all, as a scientist, but also a project manager, it's hard to ask for help because sometimes you feel like your way is the best way, and that if someone comes in to help you, they're not going to do it in the way in which you would do it. So in learning to ask for help, I would still have to be appreciative of that help, but then I also have to acknowledge that the output of that help may not be done in the way that I would have done it, but it's likely that the changes that I have to make to that is going to be minimal, and it saved me a lot of time versus doing it on my own.
Excellent and very good point. Haley, what's your perspective on pitfalls to avoid?
Yeah, those are all great. The only other one I would add would be insufficient resources. And when I say that, a lot of people think money, right? But resources can mean a lot of different things. So when I say insufficient resources, that includes time, people, space, reagents, the technologies that you need, the machinery. And what's nice about ICS is that our institute has the capability to provide a lot of those resources. So we have a space that, and we can hire postdocs for team science endeavors, and we can use this space for these programs and for these projects. But yeah, please feel free to reach out to me if you want to learn more about that. But insufficient resources is a major pitfall of team science.
That's great. So finally, I think Caitlin, you get to speak up on pitfalls too.
Yeah. So I guess I'll touch on two of them. One of them is a challenge, and I guess it can't necessarily be avoided all the time, but there are team members that might have different priorities or agendas, and that can lead to divergent goals. That can be really challenging. An example would be a team that has both academic and industry partners in it. So the academic side might be more interested in the research and advancing that, but the industry side of it might be more focused on the product and the intellectual property and kind of where that's moving. So I think getting them to agree on a shared vision can be a little bit more challenging, but can't necessarily be avoided. And then one thing that can be avoided is, on the flip side of what I said was a strength of strong teams, would be poorly defined roles and responsibilities on the team. We've seen teams have this happen, and it can cause, communication issues or lead to confusion and frustration amongst the team members as they try to move forward and hinder progress. So it's really important to define those, hopefully early on in the project, but if not, find a way to fix that and define it later in the project.
That's great. I'll just wrap up with a couple of observations of my own. I think that one of the things that I have seen very frequently is the being stuck on using a particular set of tools and not being able to move quickly to another roughly equivalent tools for a particular practice. And some people have different ways of noting how they're making progress, and certainly keeping a log of decisions that are made that we can look back on over time in order to understand why a decision was made, when it was made in a particular context, and maybe it needs to change, the decision needs to be changed at this point in time because things have moved on and we've evolved the project. And the other thing is that one thing that I've seen a number of times is that documentation can get old and stale. And if you haven't looked at a document in a year or so, you might pick it up and realize that you've changed how you were doing something, even though everybody agreed on a process early on in the project. Now things have changed, and yet you never changed that document. So as you onboard people and you ask them to read over the materials that you've assembled for a particular project, it can be very problematic if they get the impression from the documentation that a process is being done the way it was done in the past instead of the present. So I think you cannot communicate enough in any of these large groups. You have to communicate regularly, and you need to be disciplined about it. And one of the things that's my pet peeve is that we sometimes communicate only in words. And I think figures, tables, diagrams are essential for some people to be able to wrap their brains around what particular point is being made by a particular collection of words. So I think there's being flexible in how you communicate and understanding how to meet people so that they're receptive, I think, is very important. So with that, do we have any particular key takeaways? We're going to move to our retro board in just a few minutes here. And then we'll look at some of the contributions that have already been made. I would say that elements of successful team efforts, diverse experience, effective communication, collaboration and respect. I think respect is a great word to put in here. Um, Mutual enthusiasm, clearly you have to be on the same page as far as vision and goals, and a culture of collective action, and also taking personal responsibility for things that really need to be accomplished by a particular individual. And I love it when I see people step up. Then maybe moving on to other pitfalls, miscommunications or a lack of sufficient communication, divergent goals where different groups have different objectives that they are perhaps not being very explicit about following. And so you need to somehow have that discussion so that we all get on the same page again. Lack of short-term targets, which could really cause a significant amount of drift because we're not hauling on the rows simultaneously. Budget and funding challenges or resources, as we discussed very quickly. And then tool compatibility and selection challenges. Sometimes there's a long debate about which tool to use. I found that very interesting, and I've seen that happen over and over again. And then lack of project management support. Project managers are so essential to a well-run project, and their personalities and the joie de vivre that they bring to the table is essential in some cases. So with that, we're going to move to the Q&A. So overall, while team science does provide us with a lot of benefits, we need to also understand that it presents challenges, because anytime you're working in a group of social people, we have to address these challenges in order to make sure that we ensure the successful outcomes, because the program officers are looking for results, not just necessarily everybody getting along. So effective communication, strong leadership, clear goal setting are essential. And when you lack that, you're going to run into challenges. So we need to maximize the benefits of the collaborative research efforts by trying very hard to get everybody on the same page. So with that, let's shift over to the Q&A section. And I believe, Amanda, you're going to tell us a little bit about how to use the retro board.
Absolutely. So folks, as you've seen, we have dropped the Easy Retro link into the chat, and we invite you to either add your own questions by clicking on the plus sign in the relevant column. You can type your idea, and when you're finished, hit the blue box with a thin white check mark to save within the same field. Your idea will then appear anonymously on the screen for the public's reaction. And you can also upvote and comment on other ideas using the thumbs up icon. And you can comment on an idea using the quote bubble icon. You can also feel free to direct questions about how to use the board to the host in the Zoom chat.
So maybe I'll kick this off because I see a question under my name that I really am eager to answer. What role is AI likely to play in the functionality of scientific teams as we move into the future? Will it have any impact? This was a topic that came up as early as yesterday, so as recently as yesterday. So I'll just say that I do think that we're seeing increasingly that groups of students, of staff, and of faculty are starting to use generative AI techniques like ChatGPT or some of the other models that are out there. Perplexity.ai I used quite extensively now as my primary search engine. It gives you a different way of approaching problems than Google might have. And certainly it is a way of short-circuiting, making it more efficient to go about gathering materials. But the real value, and I don't think we've quite realized it yet, is being able to use a digital assistant as a team member. And it's going to be a little bit difficult for us to accommodate this, because I think we're very much used to talking to humans that have different emotional cues. And a machine is a very steady, level-headed, for the most part, device. And so sometimes you can try to probe it into moving in a certain direction, and it responds in very unusual ways. Ultimately, we'll be able to do grounding and other kind of specifically training a generative AI system on our own materials. So we'll be able to make it much more valuable for us. And I think we have plenty of examples that are starting to percolate around our campus as well as our healthcare system of where the value comes. And with that, please let me turn it over to the other panelists to start looking at some of these questions and drag some of the blue boxes over to your underneath your name and jump in.
I'll start since I just have one. So that's a really good question to how to navigate a situation where a team might have too many leaders, and that this is impacting the team's success. Actually, I like this one because I think a lot more of the time you have a problem where there's not enough leaders. Like there's a lot of people, but no one wants to be the leader. So one way to navigate this is to designate one main PI and institution, depending on how large your team is, that will kind of lead the charge. And then after that, you can develop subgroups to tackle specific problems or specific aims. For example, if you're writing a grant, like, okay, these two people are targeting or are going to do the broad impacts, et cetera, et cetera, et cetera. And then another key thing to do is to develop a timeline and designate tasks with specific names associated with those tasks with due dates. But yeah, those are 3 ways to kind of navigate that situation.
Okay, would somebody else like to jump in?
I'll jump in. So this question says, what are the best practices when setting roles and responsibilities for a successful teams? I would say some of the best practices are communication, respect for all, and also a willingness. I think sometimes if you don't set these roles and responsibilities at the beginning of the project, then you end up with a lot of assumptions as to what someone is capable of doing, the manner in which they're capable of doing it, or even just what it is that you're supposed to be doing. And so in practice, if you set those going forward, then it's like, oh, okay, so this person is supposed to be helping with this. It's kind of like it evenly divides the pie. And that way, you know what you're contributing to it. Whereas if you don't do it, I've seen instances where it was not effectively communicated, and then that caused arguments and the team dynamic just deteriorated. So just being able to say, hey, this is what I'm willing to do, this is what I'm capable of doing, but also realizing that, sometimes you're not going to communicate as effective, but being willing to say, hey, you know, when you said this is kind of how it made me feel. And those are sometimes you have to have those conversations offline. You have to be willing to say, we're not communicating effectively. How are we going to get this done if we're not communicating effectively? So being able to communicate with each other in a respectful manner, being willing to do your part in whatever project it is that you signed up for, but also acknowledging the roles and the responsibilities of each individual person.
That's great. And I'm adding a question from Natalie in the chat, and I put that under my responsibility. But let's continue on. Caitlin, there's a pretty important one under your name on looking at the variability.
Yeah, I was going to jump in on this one next, so thanks for that. So first off, there's 2 kind of project management questions that are somewhat similar. So one is, you mentioned the invaluable role of project managers. However, science and team science community seems to have generally a negative view of PMs and their role in the TS efforts. How would you interpret this discrepancy of views? And then the other one, I feel like it's kind of similar. Can you share more about how team science is different than just adding project management to scientific endeavors? First of all, I would love to see the literature or what you have on how the science of team science community views PMs negatively, because I haven't seen that. And in the science of team science meetings that I've been at, they've touted project managers as really vital to the teams. But project managers can have many tools in their toolbox, not just project management tools. We can have ways to apply the
Caitlin, I think you froze. Am I the only person experiencing that? Okay, so let's move on, and hopefully Caitlin will unfreeze here shortly. Somebody else, would you like to field a question?
I can go ahead and take one.
Thanks,
I have a
Brandy.
question. I have a question here that asks about examples of document naming conventions and how I've seen teams benefit from this. These are naming conventions on documents are really just agreed upon structures to help everybody find a document. This could be actually how you name the document. And that could be everything from, I've seen a lot of times a project name, an underscore, a date, an underscore, what specifically we're dealing with, maybe where it needs to go as a part of this project. And there are a lot of different ways of organizing that. I've also seen people do this with folder structures that help organize, or some combination of the two. Really, at the end of the day, the most important part is that you have some agreed upon way to navigate through documents, because it is really easy, especially when dealing with larger teams, to start losing documentation really quickly or make it hard for people to find. So really just some agreed upon structure is going to be really the key here.
That's great, Brandy. I think I'll pick up one, the one that was posted in the chat. The challenges around individuals recognize the limits of their expertise in deferring to others. And this person went on to say, for example, non-academic staff may not be recognized for their expertise. And likewise, those who develop and not necessarily take things to the market. So Caitlin, I see you're back. We'll allow you to finish here in just a minute. I'm going to answer this one question that's on, at least in my column. And so she goes on to say, encouraging suggestions from all, but recognizing expertise could be a delicate dance for leadership. So I completely agree with this observation. And it's one of the things that I honestly can look back at the team science activities that I've been involved in and find fault with myself for not. I mean, I try to give credit where credit is due, but I think in many cases that's not done in a formal fashion. And that, looking back, that bothers me more than I should have recognized at the time, as I now have a better sense of how much contributions individuals that are not academic, and I'm not sure what that really means, because I think we're all in the academy together. But I do think that people who don't have that master's or a PhD sometimes think that their contributions aren't meaningful, and that's simply not the case. And I think we need to find a more structured and formal way of recognizing people who make major contributions to papers, that we shouldn't diminish simply because it wasn't putting down code or writing down a hypothesis or writing some mathematics. I think people who help us get the community to go in the right direction, or help us to bring a product to market, are incredibly invaluable. And when I say to market, I don't necessarily mean for dollars, meaning bringing it to a community and making a difference. So lots of times the impacts are not nearly as academic as we might think, as some scientists tend to have a kind of a tunnel vision about this. So that's something I think is very important. With that, Caitlin, let me turn it back to you, since you froze, and I'm grateful for you coming back so promptly. Thank you.
Yeah, so sorry, my internet actually dropped, so I re-accessed it. Yeah, so I don't know how far I got in my answer, but what I was saying was that project managers can have many tools in their toolbox. It's not just project management tools. Of course, those are super valuable for keeping meetings coordinated and teams on the same page and having the shared team resources and everything. But what I was also mentioning is that project managers typically a good project manager will have a pulse of what's going on in the team. And they can really be that point person to maybe help diagnose or troubleshoot team problems if they have kind of a team science background. They can do things like helping implement temperature checks for the teams, with a little survey at the beginning of the meeting and coordinating that. The team science community also has a resource called collaboration planning, for example. So this tool can bring teams through a variety of different sections throughout that document to help them really define their vision, think through the people roles and responsibilities, their team outputs, the team culture, how their team is going to, what team processes their team will have and how they're functioning. And there's also a whole section on project management and infrastructure. And this is evidence-based and used at CTSAs across the country. So like NC Tracks Institute, and other institutes across the country would use this. So there's more to project management in the team science realm than just kind of the typical PM things. And I think bringing in those best practices of team science through the project management, or in addition to project management, can be really helpful.
Thank you, Caitlin. Haley, can I ask you to, if you would be willing to take on the question that's at the top of your column, if you don't mind, just because I think it's a very important question that when we have groups that have too many leaders, how do you address that?
So I think that's the one I addressed first. But if you, so
I'm sorry, you're exactly right. I apologize.
No,
I knew I wanted to come back to you.
No.
Let's take the second question, the distinction
Sure.
between team science and convergent science.
Sure, yeah, of course. So team science can mean like you're just collaborating with someone else in your lab that does something different than you, or someone else in a lab next to you. I mean, team science is a really, really broad term that kind of encompasses everything. I kind of think of like a square is a rectangle. Right? So, but when you get to convergent science, you're talking about groups of people who have really different disciplines and areas of expertise. I'm talking like RENC and environmental science and chemistry, or applied physical sciences and neuroscience coming together. So people that are in very distinct focuses that are in different schools on campus or in other institutions that then can come together with an idea and with their team science efforts to develop something that can be really transformative. So something that really can impact society or a specific market at large. So that's what we mean by convergent. And then how does open science play a part? I'm not sure if that means like IP versus non-IP. Is that what that is speaking to?
Yeah, I think that's exactly right.
So where ICS sits, we are in the pre-commercial space. So typically, and not always, but the teams that work with us are typically have an idea and are in development of that IP. So we work very closely with the Office of Tech Commercialization and others to help identify those markets and those areas so that IP can start being developed within the 2 years that they are in with us. But so for the most part, it's still all open science, but not always. Feel free to reach out.
Okay, we have a couple of more minutes and then we'll wrap up. Let me just throw it open to anybody who wants to make an additional comment.
I would say for the other question, whether or not I've encountered any resistance to adopting and implementing team science approaches, I would just say that the main thing would just be adaptability. Sometimes you're introducing new tools, new strategies, new ways of thinking, and I think it's just important to be mindful that sometimes people may have insecurities that maybe they're not up to date with something, maybe they're not going to know how to use something, and so just being flexible in the way that you introduce things to people and just being mindful that, hey, maybe this isn't the right group. So as a project manager, not just you doing what feels right to you and what you know of, but making sure that you're really looking to that team or the group of individuals that you're working to make sure that you're adapting in the way that works best for them so that you can have the most collaborative effect and the best output as possible.
Thank you. I'll take one more and then maybe it'll be time for us to wrap up. I just want to comment on the third question that's under my name on this retro board. With true consensus, everyone is a little unhappy. I imagine team science is similar. How do you keep everyone engaged? I think that when you have a good team science experience, people are engaged because it's successful. I think that they can feel it, see it, and it's easy to recognize. And the project officer, typically the person that you're primarily is your customer, is the person you want to report to and make happy because you want to have opportunities to work with them in the future. When they're happy, you can tell a well-humming team. When it's not that way, it is very obvious that it's not that way. And people aren't engaged in many cases. And in fact, one of the things that I think is a lesson learned is that when people aren't engaged, but they're on the payroll, you have a problem. And so I think that we have to be able to have honest discussions and make sure that we try new solutions to problems where the problem is the individual. Maybe it's their skill set, maybe it's their frame of mind, maybe it's the fact that they don't believe in the project and the outcomes, or maybe it's because they simply don't know where we are in the process of a particular project, and so they don't know how to contribute. Any way you look at it, when you have that problem, you have to address it somehow. And I think you're right. There is a certain amount of, nobody's going to get exactly what they want, but we have to work together. And I think that's why, in some sense, a democracy works when people have some common sets of goals and principles. And when those goals and principles are not shared, then, we're going to have some tension, as we're certainly all aware. And that happens in the larger ecosystem of the national political scene, as well as the political ecosystem of a smaller group in a team science setting. So this is a socio-technical challenge, and I think we need to think about it and continue to write and have scholarship in this space to understand how to do it better. I do wish there was a more formal theory than we have, but I think it's important for us to take it where it is right now, because we have to find ways of bringing more people and a greater diversity of perspectives toward really difficult problems. Let me just say thank you all so much for coming. Thank you from the depths of my heart, panel, for doing such a wonderful job. I want to make sure that you know that the next webinar is coming May 9th with Steve Fiore. He is always a very interesting person to interact with, and that'll be called Introduction to Understanding and Assessing Teamwork Processes. So I invite you to join in. And I sincerely thank you, and thank you all of the folks, the participants. We had a nice, steady group of people, and I appreciate your time and attention this day.